Okay, so when someone says, what is X? X is a letter in the alphabet. But in algebra now, arithmetic also, in mathematics, X now represents an unknown number. Yes, an unknown number of what now? So we have to refer back now to the real. We have to refer back to what can be perceived. An unknown number of what? For example, an unknown number of books. Okay, like in this example. So here you have 3 books. 3 books, which can be represented as, or which can be denoted as 3x. Here it is, 3x. 3 books can be denoted as 3x. Okay, so whenever you see x is an unknown number of what? It could be an unknown number of books. It could be an unknown number of tables. It could be an unknown number of trees. It could be an unknown number of persons. So always bear that in mind. Now, this topic now is coordinate geometry. Coordinate geometry, we are dealing with straight lines. We are going to talk about the midpoint of a straight line. We are going to talk about the length of a straight line. As module 7, we're going to talk about the gradient of a straight line. Okay. And the equation of a straight line graphs. Okay, in this module 7. All right. And we are going to do this through assignment 7, supported through worksheet 7. All right. It begins by saying mathematical modeling, taken from Wikipedia. A mathematical model is a description of a system using mathematical concepts and language. Okay. The process of developing a mathematical model is termed mathematical modeling. Mathematical models are used in the natural sciences such as physics, biology, earth science, and chemistry, and engineering disciplines such as computer science, electrical engineering, as well as non-physical systems such as social sciences, such as economics, psychology, sociology, political science. So you can see mathematical model is basically in all different disciplines. The use of mathematical models to solve problems in business or military operations is a large part of the field of operations research. Mathematical models are also used in music, linguistics, philosophy, for example, intensive in analytic philosophy. So, for example, a researcher was interested in the relationship between study hours and math score. Study hours affecting your math score. Okay, that can be happening. And he surveyed 42 students. Okay, now a mathematical model can be made now to describe how the study hours affecting the math score. So Y could be the letter used for score. So you see how score now is being translated to a letter Y. So Y can represent score, and X represents hours. So that's why we see X and Y are letters used in algebra to represent something that is real. Okay, an unknown value, but the value of something. And here is score and hours. And the model now, the model is an equation. So whenever you have a mathematical model, they're talking about an equation, a linear equation to be precise in this topic. Y is equal to mx plus c, where m now is the gradient and c is the y-intercept. So this model or this equation can describe how hours affecting score. Okay. And we're starting with question number 1. Question number 1 says determine the coordinates of the midpoint of the line joining the 2 points given in each case. Give your answers in fractions, not decimals when necessary. The midpoint of the line. Okay, so the line now we talked about in module 7 is a straight line which can have a middle point, the point in the middle of that line. And to find the middle of the midpoint of that line, we have to use this formula. Here it is. So this module is all about straight lines. Y is equal to mx plus c, but we are starting with midpoint. So here's the formula for the midpoint of a straight line. So we have 2 points for part A, 2 points, 3,2, and 9,4. So according to the formula, we must find what is x1 and y1. We must find what is x1 and y1. And we must find what is x2 and y2. The 2 points we are going to use are 3, 2, and we are going to use 9, 4. So as you can clearly see, x1 is 3, y1 is 2, x2 is 9, y2 is 4. So please apply this now to question number 1 in the assignment. So where I have three and 2, 9 and 4. Also, please do that. You will be having 4 and 7, 8 and 11. Okay. And I've labeled x1 to be 3, y1 to be 2, x2 to be 9, y2 to be 4. So we can use this formula there to find midpoint. So therefore now, the midpoint, we're going to substitute now into the equation. Remember we said that midpoint is equal to x1 plus x2 divided by 2 according to the formula. All right. x1 is 3. 3 plus, and we are using brackets, 3 plus x2. x2 will be 9. 3 plus 9 divided by 2. Okay. Comma, open bracket, y1 plus y2. y1 is 2 plus y2 is 4. 2 plus 4, close bracket, divided by 2. And all enclosed in a bracket because we're talking about a point, the middle point. A point is within brackets, 2 coordinates within brackets. So now what we are going to do now, we are going to find what is 3 plus 9 divided by 2. 3 plus 9 is 12 divided by 2. That will give us 6, but we can actually prove it in the answer in the working. Open bracket, 3 plus 9. Please make use of brackets when you are doing this, divided by 2. and that's 6. Three plus 9 is 12 divided by 2 is 6, comma, and the next one is 2 plus 4. Make sure you use brackets when you're doing this. 2 plus 4 divided by 2, and that's 2 plus 4 is 6 divided by 2 is 3. So that's where you find the midpoint of the straight line.